Okay. Using a GC to sketch a given function. Now we go on to actual work sketch using GC. A bit noisy. A bit noisy. Thank you. Are you ready? Okay. I said this is not the first time you hear of this. When we sketch, we always must have SIA. Stationary point intercepts asymptotes. But on top of that, can we be very careful to indicate the endpoints if a domain is given? Whether is it parametric or whether is it Cartesian. What do I mean? Okay. I'm going to be a bit naggy here, but never mind. I can accept it. If I sketch y equals x squared, all of us can sketch. If I say y equals to x squared and x is between, then you not only have to sketch this, you then have to say, oh, okay, you have to then indicate the endpoints. Do you follow what I'm saying? If this is given, you then have to give the endpoints. That's what I mean. Alright? Okay. Okay, the rest you can read on your own. If exact values are asked for, then you cannot use GC. Because GC can never give you root 2, can never give you log 8. Follow? Right? Okay, let's move on. Let's look at some of the more common curves. Okay lah, very boring, right? I also think quite boring. Let you see something. You want to dance or not? Who wants to dance? This one is nice. You all know this one, how this looks like or not? I bet you all don't know. This is quite good. Wait. This one. Why cannot? Why cannot? X is negative, huh? This one? Then X can take on positive values here, X can take on negative values here. Demo! Cannot. Okay. Game over. I also think quite boring, so I have to show this kind of thing. Okay, anyway. Example 10. First thing to note, if you have something like that, look here. A is an unknown. A is a constant, but you don't know what the value is. So when you are asked to sketch, you have no point. When you find SIA, when you find intercept, you still have to do it analytically. You cannot use GC. To find stationary point, you also cannot use GC. You don't know what the value of it. So you have to perform all these things, which I'm not going to do. Okay, you can do differentiation on your own and find stationary point. So after you do all this, you realize that, oh, okay, I have a point, I have all these points. Whereas this one, this is a stationary point. I don't care how you do it, you do it. 10. Correct? Just differentiate. A bit too noisy. Are you okay? Is it because there's no copying? Do you understand? Can, right? I can skip this section, right? Huh? No? No. Can, right? Can. Okay. Interesting question here. Observe that there are no asymptotes for a polynomial graph. Why? Like that, why? Really? I mean, look. Oh, sorry.
How can there be an asymptote? Say y equals to x cubed plus x squared minus 1. Whatever. Polynomial. How can there be a asymptote? As x tend to infinity, y tend to infinity. Infinity, correct? Are there any values x cannot take? No, x can take all real values. So there's no vertical asymptote. So no, that's all. Okay? Okay. Can I have attention, please? Look up. Don't look at your notes. Look up.
I say, when you have a constant a, you cannot use to find intercepts, cannot use GC to find stationary. What you can use GC to do is to get the shape of the graph. Shape only. Don't you ever try to get the intercepts and stationary point. Just shape. Then what? Then you ask me, what do you substitute for A? A is a positive constant. Just substitute anything. Doesn't matter. Let's try. So x squared x minus 1. I'm using a equals to 1. I'm doing a equals to 1. Some of you can use a equals to 2. Doesn't matter. This is the part I want to warn all of us. We get a shape. Yes, we get a shape. But does the graph really look like this? There is this part here that is an unknown. Correct?
So you can do a few things. You can do what is suggested in the notes, or you can use something what we call zoom box. Do you know what is zoom box? Yes, or just draw a box around here. Then you realize that it's like that. It's just like your iPad. Zoom in, pinch, same lah. Correct? Like pinching lah, but don't attempt to do it in your GC, okay? Okay? Okay, what I want you to do, a lot of talking, never mind. What I want you to do now is then to complete this graph on your paper. Now, is this a complete graph? No, because don't forget your SIA. Yes, very good. Here, SIA, please. Goodness. Okay. Earlier you have found this intercept A0 analytically. Earlier you have found this minimum point analytically. Okay, good, done. your primary school question, then you can buy 20 apples, 20 oranges, and then you say sweet, I don't know what they say, don't buy, don't buy. True, very true. Anyway, okay, let's come back. Let's come back, come. Have attention, please.